do you have any manual way to calculate sine 15 degrees? Means can you find out without using calculator yourself, some layman method? If you have, please message me privately. Next, in class 10 we have learnt to calculate the values of 6 trigonometric ratios for the angles, for some specific angles, and those angles were 0, 30 degrees, 45 degrees, then 60 degrees, and then 90 degrees. We could calculate the values of sine, cos, tan, and in fact all 6 trigonometric ratios for these angles only. Okay, and how did we calculate the values for those? By using geometry and algebra, combination of geometry and algebra. Recall that. Okay, so now we are able to find out the values related to these angles only. So, means we can find out sine pi by 6, we can find out sine 5 pi by 6, and so on, or pi by 3, sine 5 pi by 3, or sine 2 pi by 3. Okay, if I ask you to find out sine 15, you won't be able to find out. Okay, so now we have to develop some method to find out these angles too. So either we have to go through the geometrical procedure which we adopted for this, means whatever way you have, if you have some way, you have to message me. Okay, right now, apart from the geometric way or any logical method or any other method, we are heading towards a algebraic way to find out the values of 6 trigonometric ratios for some other angles too. Okay, and that method is by using these angles only, by using the combination of these angles. And how is that? Just like sine 15 degrees, or let's not take 115, let's take it 105. Yeah, let's take this. Now this can be written as a combination of these. Okay, how come? Because this is actually equals to, we can write it like 60 degree plus 45 degrees. Okay, now if you are thinking that this is sine 60 degrees plus sine 45 degrees and the problem is sorted, then you are completely wrong, because this is not equals to this. Why? Because sine theta is not equals to sine into theta. They are not two different things. This is incomplete without this, and this is incomplete without that. Okay, sine theta is a one thing. If I ask you find out sine or theta, okay, sine has its existence because of theta. Sine has infinitely many values for different theta. Once we substitute a particular theta, then we can find out a particular value. Okay, and they are not multiplying with each other. So when they are not multiplying with each other, okay, then how can we distribute it like multiplication, sine into 60? So I was not talking about this algebraic method. Okay, so the problem is still there. We have to find out an algebraic method which use the combinations of two known angles, means how to sort it out further. For this very reason, I gave you a sheet in my previous module, okay, where I targeted that you will end up with something like this. means we want a formula for this which is not equals to sin x plus sin y. We want something like that. Or the same problem can arise with cos 105, so we want a formula for this. In fact, with all trigonometric ratios, we need formula for the combination of angles so that we can find out 6 trigonometric ratios for some angles other than these. Okay. For this purpose, I gave you the sheet, but there I made a mistake that I didn't mention you the objective. What's the objective of this sheet? I suppose you all will end up with the same thing. But in the beginning, many of you took different directions. How come? As very first step, I asked you to write down the coordinates of the 4 points given here in the figure. You know the coordinate of this point can be written in, means I thought of you'll write it in the format as I supposed, but you went in more direction, which is not wrong, but actually failed the objective of this sheet, this activity. How come? Let's focus here. Suppose this angle is theta and this is any point on the unit circle. You can find out how can you write down the coordinates of this? Okay, we know the x coordinate for this, which is from here till here. The x coordinate of this, okay, is this. Visually it is this, and the y coordinate is this. But simply the x coordinate can be written as cos of x and sine of x. This is actually called cos of this, and this is also called sine of this. This is how we started our full chapter, taking trigonometry beyond 90 degrees. Okay, and why do we use cos x this here? Means suppose your x is 45. Okay, then why do we? It cannot be 45. Let cos is let this angle is 145. Suppose. So, what's the coordinates of this? Cos of 145. Okay, we don't use it like 180 minus 145 is cos 35. Okay, if it is 145, then it is gonna be 35. And for according to you, this distance is cos of 35. We don't use it because it's here also. Okay, so initial means we cannot say cos 35 only. It's cos x and cos sin x, and later this can be sorted out like cos of 35 and sine of 35. No? So this is what you did. When I asked you to write down the coordinates of this is one try. I suppose you'll write it, but you went one step ahead and you wrote it that the coordinates of this is cos of pi minus x and sine of pi minus x. You took care of all sign conventions. Okay, and this is minus, which is perfect. No issues in this, because how does okay, suppose this is also 35 degrees and that is also 35 degrees. Then how does the coordinates of this, how does these two positions differ? Okay, its coordinates are cos of 35 and sine of 35. Okay, obviously this is cos of, this length is, distances can never be negative in that way. Signs are only the directions. So this distance magnitude is cos of 35 and sine of 35 only. Okay, but as this position is different from this, so that's why we used cos of minus cos 35 and it is sine of 35. Okay, in that ways. And broadly, how do we represent its coordinates? It's cos of this angle. Okay, means cos of 145 degrees is this, and sine of 145 degrees is this. Initially, I didn't mean you'll sort it out further. It's not wrong. So we got the point. Means I suppose you'll do this, but you did this. Now when I planned it, I thought you'll write here it's 1 and 0, and I thought you'll write it here. This is your AC, and A is at an angle of x. So I thought you'll write here cos x and sine x. Okay, and here you'll write it this C. You'll write it because for this I didn't mention any angle here. Okay, so this can be calculated either by using this angle or by using that angle. Okay, so I purposely didn't give you this full angle so that you left with one option only, using this angle. So I suppose you'll write this one, the coordinates of C, as cos of minus y and sine of minus y. Okay, and for this the clear-cut angle was x plus y. Then I thought you'll write cos of x plus y and sine of x plus y. Okay, then what was the plan further? That you'll do this, which you all have done. Okay, AC equals BD. See, if you apply distance formula here, what do you have? Cos x sine x, cos minus y sine minus y. Okay, and if you apply distance formula in BD, what will you get? Only cos of x plus y and sine of x plus y. So here we had a combination of angles, and here we had the simple angles. While applying distance formula, I suppose here on BD, when you'll apply distance formula, okay, so you'll get this minus 1 whole square and this minus 0 whole square. This is the x1 minus x2 whole square, y1 minus y2 whole square root. Okay, so you would have got this minus 1 whole square and sine x plus y minus 0 whole square, which would be this. So when you sort it out, this will add up to 1 and something, and in this equation you will be left with cos x plus y and some additional constant terms also. That was the target, that on one side you will get this, okay, cos x plus y. This is while solving your BD. Then while solving your CD, you won't be having the combination of angles x plus y and x minus y, something like that. It will be cos x purely, cos minus y purely. Okay, so and when we'll equate AC and BD as per this, so we'll develop some formula. Okay, but you wrote these in terms of two angles already. Means instead of cos x you wrote it pi minus x, and here also you wrote something else. So you developed the formula in terms of a plus b only. So just like Samya has her final formula, it's like, means where did you end up? There's no issue with your proceedings, but your answer is like cos of pi minus x. Means you have a formula which is again complex, means not serving our purpose. Okay, so now you will redo this exercise of yours. Okay, you'll use these combinations so that we can develop the formula that we are targeting to. And one more thing I want to add here, that is how to deal with this cos minus y and sin minus y. Many of you know it, still I'm telling you. Okay, suppose we have this unit circle, and now we have this plus, we have to deal with this plus and minus theta, and there cos and sin values. First let's deal with cos. Suppose this is any angle theta. Plus theta and minus theta means the same angle but in the reverse direction. This is your cos theta and this is your theta and this is your minus theta in the other direction. So what is cos of this? Cos of this means, cos of theta means cos of this position. Cos of minus theta means cos of this position. What is the cos value for this? Okay, if we see here, the cos value for this is this. The cos value of this is this. Means if your theta is same, these 2 points are equidistant from this on this arc. That means these are almost congruent then. No? You can say angle, common arm, and these are radii, they are congruent. Okay, so their sine components are also same and their cos components are also same, and the cos component is this and the cos component is exactly same. So what is this? Cos of plus theta means cos of this position and cos of this position, they are same. So whenever we have, okay, let's take one more example. Suppose now you have this angle. Okay, let's take it x, or let's say this is the theta now. Now this is the theta, or you can say this is theta 1, theta 2. Okay, so what is this? We went theta 2 degrees or radians from here to there. If you go theta 2 but in the reverse direction, so you'll be somewhere here. And same amount of revolution, because just the direction is opposite, rest the magnitude of the angle is same. So this is minus theta 2. Okay. Now what is the cos component of this point? Okay, either you can say cos component is cos theta 2 and here it is cos of minus theta 2, cos of obviously this angle and cos of obviously this angle. But if we sort it out, means if we solve it, so basically cos of theta 2 is actually minus cos of, means this is this is the cos component of this position, and how much is this? Minus cos of which angle? This angle, no? Which is pi minus theta 2. We have used, okay, this whole. Now here, for this, how to find out cos of minus theta 2? We know the cos of minus, same distance. You can see visually they are same. No? This and this. Now, but still, cos of this, how do we calculate it? It's actually, these two angles are only to locate the points. Then we calculate cos and sine as per this angle, no? So cos of minus theta 2 reached us here. Now we have to find out this value. So this told us that we are in the third quadrant. Okay, and the cos value is this only. How do we calculate it? By using this angle. So first thing, this tells us the quadrant. So this is minus because it's in the third quadrant. And the value is, how do we calculate this? This is cos of, what is this angle? This full angle is pi. So this angle is pi minus theta 2. Okay, we won't write here pi minus theta 2. Don't mess up with this algebra here. This is clear cut thing here, that this angle was just to reach here and this angle was just to reach here. This is the role of this angle, no? Once we reach here, we have to find out this. And how much is this? You know it is negative. And how much? Now we are calculating the magnitude. And magnitude is with respect to this angle. And how much is this angle? It's simply, now just get out of this negative and all. How much is this angle? It's simple. Your plane geometry. This angle is pi and this angle is pi minus this angle. And how much is this angle? We just have to subtract the magnitude. Forgetting this. No? Just like your simple. How much is this angle? It's this minus this. We are using it for some algebraic purpose. Okay? Minus theta 2 has served its purpose. So this is minus cos pi minus theta 2. Means simply, if we want this angle, this is 180 minus this angle. And this angle is actually the magnitude, whatever is the magnitude. So we have got actually the same. What did we get? That cos of theta 2 and cos of minus theta 2. They both are same, as they both are equal to the common term cos pi minus theta 2. That means, so the thing is simple. Okay? Means if we go theta 2 and if we go theta in the positive direction and the same theta in the negative direction, we will get the same value. Okay, because if we go theta 2 in the, if we go some theta and we land up in the first quadrant, then here we'll end up in the fourth quadrant, and for first and fourth the cos value is same. Okay, if we land up somewhere here to here, then in the negative direction we'll end up here. Okay, so this and this, and second and third quadrant has the same, means the cos component is negative in both. Okay, and if while dealing with this positive theta, if we'll end up here, this is your positive theta, suppose. Okay, if we'll end up here, then from negative we'll end up there, and obviously the cos component of this point and this point are gonna be same. So what did we sum up? That cos of minus theta is actually equals to cos of theta. Okay, cos of any angle minus theta is equals to cos